Compare compile time polymorphism and runtime polymorphism. So polymorphism means one name, different work. One function, different row. For example, in our function, if we write add, this is the name. Now there can be multiple add you can write, same name. The only difference is the signature, that is the input parameter and the return type. It depends on the input types and return type what function is going to be called. So in compile time we have function overloading, operator overloading. In runtime we have the function overriding, and we implement it using the virtual function. So let me tell you the difference one by one. First is, in compile time polymorphism, we would come to know at only compile time which method will be called. That is, you have written a program, then in your IDE you have compiled it. So when you compiled it, you have not run it, you just checked for the error whether it is working fine or not. We have never gone to the running, actually not given to the processor to work, only the compile time. So compile time polymorphism, we would come to know at compile time which method will be called, and the call will be resolved by whom? The compiler, only the compiler, right? Runtime polymorphism, here we come to know only at the runtime which method, which function is going to be called. So this is not resolved by compiler. Compiler cannot resolve it. The compile time polymorphism, it is faster. Why? Because we already know at the compile time which function is going to be called. But here runtime we need two steps. First we have to compile and then the running. So it takes a bit more time. So it is slow execution as compared to the compile time. How do you achieve this compile time polymorphism? This can be achieved by two methods. The function overloading, this one, and the operator overloading, this one. In C++, runtime, it can be achieved using the virtual pointers, virtual functions, and also the pointers. Basically, it is function overriding. Let us take an example. Now, this is the example of function overloading. Now you see we have two functions, exactly same name. Only the signatures are different. That is, in one we have two integer types as the formal variable or formal parameters, and inside the second one we have three formal parameters. So whenever we call add and we give two values, that is 2, 3, and the second one we call three values, we gave three values. For two values, this function will be called the first one, and for this second function will be called. Okay, this is function overloading. This is compile time polymorphism. Now come here with the runtime polymorphism. In the runtime polymorphism, it will only happen, we only talk about this when there is inheritance. That is, we have a base class and then we have a derived class, and they both have the same function name. Okay, let me tell you here. See, we have a class A, this is called the base class. Now we have a class B, which is the derived class, it is derived from class A. Both have the same function name, fun, fun. But why we have used virtual in the first one? Because when we'll make the object of the derived and we would like to call it, it will be directed to A every time. But by writing virtual, actual derived class function will be called. If virtual is not there, every time the only base function will be called, not the derived. But once we have defined it as virtual in the base class, now we can call the derived class function which are having the same name as the base class function. I hope you got the idea. No virtual, only base class function will be called. Virtual, the derived function will be called, because they both are having the same name. So this is runtime polymorphism. This is method overriding, and we have achieved it using the virtual function. So the virtual runtime polymorphism and compile time polymorphism, this is the difference, but the same function, same name.